Hello everyone. Thank you so much for watching our presentation. We are Group 3. I'm Mahya Nazarisharabian and my group mates are James Ragan, Stela Shrestha and Kanchan Phuyal. Our presentation is consists of 6 parts, including introduction, work breakdown structure, site location plan, MS project schedule, quality metric, and conclusion. First, let's get familiar with this project called Mojave Bloom. It's a solar-powered high-performance home specifically designed to support military veterans returning from service, especially those experiencing PTSD or traumatic brain injuries. The main goal is to create a living space that's not only energy efficient, but also healing, safe, and supportive for their well-being. Some of the key features include the use of high-performance renewable energy systems, which means the home relies heavily on solar power and smart low-energy technologies. The design also focuses on water efficiency and reducing environmental impact, which is extremely important in a desert climate like Las Vegas. Also, it supports partial off-grid living with smart and low-energy systems. The project is located at UNLV's Paradise campus on Tropicana Avenue. And about the modular construction approach, 10 prefabricated modules built by a local fabricator are delivered sequentially and assembled on the project site. For developing a work breakdown structure, we consider drawings and main phases of work that are including pre-construction, fabrication, module delivery, installation, envelope work, MEP, interior work, and closeout. We did it by considering that we have 10 repeated module building components. This is a level 5 work breakdown structure of the project. Each level is specified with specific IDs and colors. Level 1 is the name of project, UNLV Solar Decathlon project. Level 2 are the main parts of the project, including pre-construction, module fabrication and delivery, module installation, MEP system, interior works, and closeout. If I want to talk about the whole WBS, there are a lot of activities. So I just want to explain the first part, which is pre-construction. Level 3 of this part are project start, site establishment, and site preparation. Sub-activities of project start are permits, submittals, and procurement. Sub-activities of site establishments are site office setup, providing welfare facilities and fencing. And for site preparation, two sub-activities, which are level 4 of this part, are earthwork and grading, and also foundation. Sub-activities of foundations that are level 5 of WBS are pad and excavation, and the other one is seismic fear installation.
Thank you, Maya, for providing the essential details of work breakdown structure and answering the question about what kind of activities. Now, I'll be talking about when and how to do these activities for the completion of the project. Hello, everyone. I'm Stela Shrestha, and I'll be talking about the sitemap and MS project part of the presentation. First, talking about this slide, we have a descriptive map with the position of symbols and the descriptive legends on the right-hand side. You can see a red box in the bottom half of our site where we have the laydown area, and the green box represents the modules. The bubbles with A1, A2 are the area codes assigned to the position of the modules, and the crane position is placed right above the red box so that it is near to the module storage area and the laydown area so that there's optimal movement for the crane. And we have all of the other things like the dumpster, the material storage area, the laydown area, delivery area, office trailer positioned in such a way such that there is less conflict and more organization of how things work on site. Now, we use MS Project to do the scheduling of our project. The MS Project has a detailed the MS Project was done with a detailed baseline schedule and logistical planning. We have listed all of our activities and given the corresponding duration and links to them such that all of the activities are linked Along with that, we have also assigned resources to these activities. We have also provided schedule reserve as specified in our project that acts as a buffer to uncertainties. This is the resource sheet of our project that encompasses of stakeholders, equipments, and the materials that are used in our project. This is a network diagram that consists of all of our activities. Here on the left-hand side, you can see summary activities listed. On the top, we have milestones. We have a reporting date of November 24th, and that means that all of the activities before that date are completed. As you can see the zoom box, here we have a red node representing the critical activity and the blue node representing the non-critical activity. Critical activity, if completed, is represented by a single dash. Non-critical activity, if completed, are represented by double dash. And after this, we have a detailed Gantt chart. Thank you.
Thank you, Stella, for explaining our MS schedule. Now we'll go through the result of our metric analysis assessment, where we have the metric analysis table, where we have metrics, which is a quantifiable, simple, and understandable measure used to compare the performance. We have threshold, which serve as the maximum or minimum value as the benchmark for the comparison, and a baseline schedule, which is a benchmark against which the project performance is measured, and an updated schedule, which is the current status of the project after the changes is applied. We began our assessment by using baseline schedule as our project benchmark, where we got 22 metrics pass out of 30 metrics, and after updating the schedule we got about 24 metrics pass out of 30 metrics. This improvement reflects significant enhancement in how the project can withstand risk and delay. The key observation obtained from the metric analysis assessment were about 40% of the activities of the baseline schedule were on the critical path, which reduces the flexibility of the project and increases the risk of delay. So we redistributed the dependencies, which leads to 27% of the activity to be on critical path, that reduces the critical path congestion and increase non-critical task. These changes enhance the schedule resilience and improve the project efficiency. This is the pie chart we obtained from the updated schedule, where we got about 24 metrics pass out of 30 metrics and 5 fail with 1 not applicable. This is the detailed table we got from the updated schedule, where we have project dates, schedule details, activity status count, and relationship type count, where project date include report date, notice to proceed, and estimated finish date, and schedule details have number of activity, where we have 119 activities, number of milestones, number of relationship, number of activities with resources, and activity status count we have not started 69 activities, and in progress we have 2 activities, among which 97 activities are completed, and the relationship count we have only finish to start relationship among the finish to start, finish to finish, start to start, and start to finish relationship.
Thank you, Kanchan. I'm James Ragan. The following are the conclusions and results for the Group 3 UNLV Solar Decathlon project. The updated schedule that was developed by using the baseline schedule and applying the 30 metric assessment analysis has made our schedule more well organized and aligned. That can be demonstrated through the increase in the pass rate of the metric for baseline schedule from 73% to about 80%. We analyzed the Mojave Bloom project to understand the purpose and the design goals of the project. The timeline was created showing critical sequencing and dependencies of activities in the schedule. The schedule supports the cost, scope, and time of the project. The baseline schedule report was developed and delivered to support the baseline schedule, which serves as a reference point against which actual project performance can be measured. A reliable schedule was created by capturing all activities in the formation of the work breakdown structure, with a majority of the predecessor and successor tasks joined with finish to start relationships and constraints and lags minimized. A critical path through the construction project was defined. Horizontal traceability was shown and vertical traceability was displayed. The construction build-out phase of the project includes summary activities. Group 3 produced and delivered. The schedule quality metrics were established to show how reasonable a schedule is and to determine if activities met the threshold parameters. The activity metrics were analyzed for a baseline schedule and an updated schedule. There was an improvement in the schedule through metrics analysis. The schedule shows linear scheduling for the sequence of similar activities. For example, the ordering, delivery, and erection of modules. The schedule supports key project indicators of cost, schedule, quality, safety, and teamwork. Although compared to the baseline schedule, there's been an improvement in the number of critical activities that were previously 40% and that were brought down to 27%. But to pass the metric, this number should be brought into the 15 to 20% range. This can be done by updating the lengths of the activities, breaking off activities with long durations, developing more parallelly linked activities, add additional float, and also conducting regular supervision to ensure that the project goals are met. Our reference was the AAC EI 38R06 documenting the basis of the schedule. Thank you for listening.